Aloha class, here we go. Improper integrals continued, okay? We're on example 11, and I got the best mints ever. All right, so here we go. The comparison test. Sometimes we cannot find the antiderivative of an integrand of an improper integral. We might be able to draw a conclusion if we can compare it to something similar for which we know something. Well, comparison test ends up being a very important topic from here on out in BC. And what it is we have a comparison test. Sweet, right off the bat. I don't think my marker works. Well, that's a great way to start a video. Okay, so let's try this bad boy blue one. Let's hope it's okay, good to go. All right, so comparison test for convergence or divergence, okay? So we're gonna say f and g be continuous functions from a to infinity, okay? And then we have this relationship, okay, where 0 is less than f, which is less than g, for all x greater than or equal to a, okay? Now, if this is true, and we have an improper integral that converges, then we can say f converges too. Vice versa, if we have an improper integral and f diverges, then that means g of x would diverge too. So hopefully it makes sense that if this converges and this is bigger than f, this also has to converge. That's the first bullet point right there. Vice versa. Okay, let's say that this diverges. This answers infinity. And if this is less than this, then that has to diverge or be infinity also. Now, this is going to make a lot more sense as we go on to examples, but for some of us, it's going to take a while for us to get used to this, okay? But here we go. Let's start with A, okay? And our problem is this guy right here. And there's no way to find that antiderivative. So since there's no way to find that antiderivative, I'm going to use this very important information they gave me right here. Now, how am I going to use that information? Well, this guy looks really, really familiar to me. And if I turn that into an improper integral, hopefully we remember from earlier before that that converges, right? And we actually found that that converges to 1 over e, but it definitely converges. Now, as long as I have the correct relationship in this inequality, I could also say that this converges also. Now, hopefully it makes sense. Okay, for example, this converges to 1 over e. Does that mean that this could possibly diverge? There's just no way, right? Because it's got to be between 0 and 1 over e. So guess what? All I have to do is a little statement for this guy. So we write since, okay, since the integral from 1 to infinity of e to the negative x dx converges. Now, if this was an actual AP exam, you would have to show this using improper integrals, right? But we did that already, so I'm going to save some time. Okay, but since we've already showed that this converges, and it's very important that we have this inequality, okay, this has to be true. If this is not true, then I cannot make the conclusion, okay? Since that is true, we know that the improper integral from 1 to infinity of e to the negative x squared dx converges as well. And then we make sure we say by the comparison test. Okay, that's it. So it's just being able to recognize relationships. Okay, and that's the whole point of what we're trying to do here is recognize relationships and use that kind of property that we started today's lesson with. All right, let's look at this one because this one's a little bit more difficult. Okay, and I want to know if that converges or diverges. Okay, and they didn't give me an inequality to get started with, so they didn't give me any hints. Well, it could make maybe a little bit more fun. Well, a lot of side work here to get started, okay, because we need to find a relationship, okay, and we want to use something that we know. Okay, so we got that guy right there. Okay, hopefully it makes sense that cosine of x is going to fluctuate between -1 and 1, right? That's its amplitude. So if you were to do 2 plus -1 or 2 plus 1, the smallest that could ever be is 1 over x, right, class? And guess what? Ding, 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 ding. 1 over x is kind of like a light bulb. Why is 1 over x a light bulb? Well, I could relate that to the integral, right, of 1 over x, which happens to be a p-series. And we learned earlier, and I could prove this, right? by doing an improper integral, but we already did this, so I'm not going to do that again. But we saw that this diverges. Okay, well, if it diverges, I need a specific relationship between 1 over x and 2 plus cosine x over x. Okay, and what is the relationship? Well, the relationship would have to be this. This is the only way that it would be helpful. Okay, now why am I saying that's the only way that it could be helpful? Well, if that diverges and this guy over here is bigger than it, it would also have to diverge. Hopefully that makes sense, okay? The other way I could write that inequality would be like this. Okay, and remember, we want to use the result to make a conclusion. Okay, that's the only other way. Which one of these guys works? Let's see. Okay, for one, this diverges. If this diverges and it's bigger than this, does it mean that has to diverge? No. So that would be too inconclusive. Could it? Maybe. But this actually would work out if it was true. So now you just have to make sure it is true. And it is, right? We just did it earlier. Okay, the smallest this could be is 1 over x, right? Because cosine is going to fluctuate between -1 and 1. So believe it or not, this will always be bigger than or equal to this. So guess what? I am done. I can just say since the integral from pi to infinity of 1 over x dx diverges. Now, how do I know that? Well, if it was an AP exam, you would have to show that using some side work, okay? And you always have to have an inequality. Now, the only way the diverge statement works is if what you use that's diverging is in the middle. And this has to be true. Okay, but that inequality statement is 100% true. So since both of those are true, we can say we know that original problem, the original problem that I was unable to find the antiderivative of, so I'm using the comparison test, right, diverges as well by the comparison test. All right, how about it? Not bad, not bad. Okay. All right, now I challenge you to try C on your own. Okay, we'll do it together, but hit pause, try C on your own if you're kind of getting the hang of it. If not, it's kind of tough. Okay, so let's go ahead and look at this. I'm going to erase to make sure we're good. We got to do a whole bunch of side work. And side work for this is investigation, right? Is that French? Investigation. Maybe that's French. I don't know. All right, here we go. I have to investigate 2 over x plus e to the x. Well, that looks like a couple of things. That looks like 2 over x, which if I put an integral in front of that, right, and go from 4 to infinity, that would, let's go ahead and do it. That would diverge. Okay, that would diverge, right? Okay, and we could do that. We could prove that, but we did it earlier, so I'm not doing it again. And then we have this guy, 2 over e to the x. That looks very familiar, right, class? But that, believe it or not, converged. Okay, how do I know that? Well, I could prove it, right? But we already did. An actual AP exam, you would actually have to prove that, okay? But the question is, which one of these guys do I use? Well, let's see. If I want to use this one, the diverge one, we just said that that has to go in the middle. Okay? That has to go in the middle. It's the only way I could use this diverge thing productively. If it converges, that guy's got to go at the end. Okay, so the problem I'm doing then would have to go in the middle. So the question is which one of these is true? So let's do a little exercise. Okay, because if I'm comparing these guys, okay, to this, okay, you should notice that that is definitely bigger in the bottom than both of those guys. Okay, so let's just look at a fraction. 1 over 2, 1 over 3. 3 is bigger. Oh, but it's smaller. Okay. So if I have like 1/5, that 5 is bigger, okay? But guess what? It's actually, as a fraction, smaller. Does that kind of make sense? So since this is bigger, this has to go in the middle, which would have to go right there. Does that make sense, class? Because this will always be bigger than this, and that is a false statement. So that means I'm going to use this piece right here, and I just have to write a statement. Since the integral from 4 to infinity of 2 over e to the x dx converges. Right, class, it converges. How do I know that? Well, go do side work and prove it. But we've actually already did that already, right? And I have to have an inequality, right? And the inequality has to be 100% true. Okay, this guy is always smaller than this guy. Oh, it worked out beautifully. If that converges, that has to converge, right? We know that the integral, the problem that we were unable to do, right? Because I couldn't find the antiderivative of that. I don't know. Maybe you could. Whoops. Well, converges as well by the comparison test. Okay? One more. Come on now. Come on. Challenge yourself. We just got one more to go. Here it is, D. Okay, and I challenge you to try it on your own. That's how you're going to learn the most. Side work investigation. Okay, so this time it's 2 over x minus e to the negative x. Okay. Well, that's going to be small. That's going to be small, which means the fraction will actually be bigger. So that's actually going to be bigger than this right here. Okay, but let's go. Let's go through this process again. 4 to infinity, we know that this diverges, right, class, by earlier. We know that this guy right here, the only other thing I could compare it to, right, we know that right there. Oh, snap. That's actually pretty interesting. That's 2e to the negative x, right, class? That'd be 2e to the x. So that actually would diverge as well, okay? So the question is which one of these guys would I use, right? 2e, yes, okay. So which one of these guys would I use? Well, and able to use, we're more familiar probably with this guy, so let's see if that's true. And the only way that I can use that is if it diverges, it's got to come in the second half. Because if that diverges, it means this has to diverge. Right, class? Oh, snappity-dappity, that is incorrect. What are you doing? It's got to be in the middle, right? Because if that diverges and it's smaller, then that means this has to diverge. So if for some reason, let's check it out. If this is true, then that means I can use that very cool statement right there. So let's check it out. Okay, so this is a number that's smaller than that. So let's see, we got 1/4, okay, right there, and then 1/3, right? It'd be smaller. So, oh yeah, sweet, it works out, right? So it's this is going to be true. So guess what? Denzo, right, class? So we're done. So here we go. We should say since. It's just a little statement. See if you can write it on your own. Since the integral from 4 to infinity of 2 over x minus e to the negative x dx diverges. Ooh, shame on me. That's not what we know. Okay, it should be since of 2 over x diverges, dx diverges, and we have our inequality statement, which is always true on that interval. Okay, we know that this problem that I was unable to find the antiderivative of, we know that this bad boy right here diverges as well. Say it, class, say it, by the comparison test. There you go. How about it? Under 15 minutes. Okay, make sure you look at those. There's not many more of those to practice. Aloha.